Hi everyone. Today we will see how to build a semantic search and question answering system which can answer questions from your own data. Let's say your own documents or your own enterprise, data using Pinecone and the LangChain. So we're going to use LangChain as a framework and the Pinecone as a vector database where we're going to store your documents, and this is how the overall architecture look like. But first of all, like, why do we want to build such a system, right? Why do we want to provide a documents and then we want to get answer from those documents? Why can't we use directly a chat gpt or a GPT-4 model and get answer from it? The reason is, sometimes the GPT-4 and GPT, those models has been trained on whole internet data, and they produce factually incorrect information sometimes, and you don't want to rely when it comes to knowledge on those particular models. Rather, you want to leverage their reasoning capability but not their knowledge. That is the one reason. And as you don't have a control over what kind of thing it is going to answer, sometimes or most of the time you want that the answer should be taken from our own knowledge base or own documents, and that is the reason you want to make sure that you give those documents like your PDF documents or whatever those documents to the model. But as we know, what if you have hundred or thousands of documents, right? You can't pass all those hundreds and thousands of documents to the GPT-3 model as a context and get the answer. So you need a way to make sure if you have thousands of documents, you can narrow down those documents and only take, let's say, top three or top two documents and then give it to the model like a GPT-4 to get the answer, right? So we will go through this architecture, right? How we make sure, so first thing is actually, let's say you have your documents. It could be your PDF, text document, your web scraping pages, all these things. Let's say you can take this document and convert those document into the small chunks using some kind of a text splitter. So rather than treating one document, right, we can make the chunks of those documents, and then semantically we can match those chunk and find out which is the most relevant chunk which can answer that particular question. So that is the reason, instead of taking whole document, we try to split that document into the chunks, and then we want to generate the embeddings because we want to match two things. One is the document chunk and then the query or the question user has asked, right? And to do that matching, we're going to use, let's say, semantic search, or we're going to use embedding to do those matching. So in both the case, whether it is user query or whether it is the chunks generated from your documents, we need to generate the embedding and store those embedding a vector DB, and that's where this Pinecone comes into the picture. That this is a store where we can store our embedding vectors, and it has you can access this as an API. We have also covered that particular thing in the other video. So I had already covered one video, that how to use semantic search with GPT-3 and Pinecone. But this time I'm going to leverage specifically, let's say, LangChain, and show how to do those same thing with the LangChain. So now once you got the embedding that you stored in a vector DB, next time when query comes, you get the embedding, and then you, let's say, use the semantic search or, let's say, cosine similarity, and get the relevant document with respect to this query, because all those documents are stored here in the form of chunks. So you will get your own query that you ask, and as a context, you will get the relevant documents. Now you can take this query and the context and give it to the question answering model like GPT-3, GPT-4, or ChatGPT, and then it can generate the answer. So rather than giving directly query to the GPT-3 or GPT-4, what we did actually, we told GPT-3 or GPT-4, rather than answering from your own knowledge, take this query and we will give you the context, and make sure you answer from that context and not from your own knowledge. So, and that context is coming from the relevant documents, right? So you could decide whether you want top three chunks or top five chunks, and you can configure this. So this is what we're going to build actually in this video. This is the overall architecture. When we go through the code, it will be more clear, what we're going to do. So let's go through the code. Let me, kind of, I would say, let me zoom a bit so that we could see what we are doing. Oh, I just exposed my key. Anyway, I can delete this key, or maybe, I will cut this part. So we could see we have, first thing we want, actually, we want a LangChain, which is a framework that we're going to use, right? So LangChain is the framework that you can use this framework and build the application on top of large language models. When I say large language models, like a GPT-3, GPT-4, those are the large language models. And this is the framework which provides multiple models. Like you can use models from, let's say, OpenAI or other providers, right? And then you could also see how to structure your prompts. Then you can create indexes, which is nothing but like those vectors store what we're going to see. And it has a concept of chain is nothing but, as name suggests, you're going to combine multiple components to achieve something. So it has more than uh, what we're going to see here. So in this particular tutorial, we're going to see how to use this LangChain actually, to build something like semantic search and question answering on your own document kind of a thing. That's what we're going to see. So we will go through the code, and whenever we need a reference, we will come here actually, right? So that's in short, the LangChain is the framework which allows us to build a application on top of large language models, right? That's what it does. So we need to install the LangChain, and we also need, let's say, the this OpenAI library. So let's first install those two libraries what we want, right? LangChain and the OpenAI. Let me run this thing. And then I'm going to store OpenAI key in some environment variable that can be used, right? Now once the LangChain and OpenAI installed, next thing we want actually some other dependencies. So here we could say we are loading unstructured. Where do we exactly need this thing? So what we're going to do actually, we have a one, let's say, directory called a data, and we have a couple of files here. So I kept one file as a PDF, one file as a text. So you can think of these are your own documents, right? Your company documents, or the scrapping files, whatever you have it, right? So we want to load these files, read content through it, and then create chunk out of it. So LangChain provides some utilities, right? So one of the utility they provide for the document loaders called the directory loader, right? So here is the reference I put so that you can go and read. So we're going to use a directory loader, which is nothing but an utility using which you can read a directory. And that's what, let's say we have directory of your files, right? And what this directory loader does, it has a loader class called unstructured loader. And this unstructured loader, as the name suggests, it is going to actually load a different kinds of files. It could be like text files, HTML, PDF, images, and all these things. Currently, we have text file and the PDF files, and then it has its own dependency to this unstructured file loader, and those dependencies is what we're going to actually install here. And this another dependency is popular utils. It is also related to the PDF thing that we want to read. So I try to cover one text and one PDF so that we can install all these dependencies. Okay, so meanwhile it is getting installed, let's look at the code which actually loads our document. So from the LangChain document loaders, we're going to use a directory loader. So there are different loaders are there. For this, since we have data in the directory, we're going to use the directory loader. And then when we have one small function which simply takes the location of the directory and then uses the directory loader, which loads the documents, and eventually we simply get the list of documents that got loaded. And here we are calling that function and printing here how many documents we got, right? So this got installed properly. Let's run this function so that we could see how many documents we got from the data directory. Ideally we should get two documents that we got from the this particular directory. So it might be loading those whatever the dependencies what we have installed, and we should see that two documents it has loaded. I'm not sure why it is taking this much time. Most likely I think it could be one of the model actually that we have. Okay, it loaded. So we could see it has found the two documents. Sorry, it has found the two documents here. Now Since we just don't want these documents, right? You see, we have these documents and we want to split those documents to create the chunks. Now the LangChain also provides an utility to create the chunks. That is the reason we are using actually the LangChain, so that we have all the utilities, that we could have done this thing, all these things, maybe writing some manual code or something. So let's go and check once again. Once we got the documents here, right, we could use another utility. So we have a something called text splitter. Here also I put a reference, so you could see the text splitter is an utility which is going to split your text into the chunks. And the default recommended splitter is a recursive characters text splitter. So it is eventually going to split the text by sub paragraph, then going to split it by line, and so recursively it is going to split. So you can read more about it, but so you can just think of this particular text splitter is going to take our document and return the chunks that we want. And it can also take certain parameters. So this is the we are importing that text splitter, and then we created one small function which actually takes our documents. And the chunk size, since we're going to create the chunk, this is like how many characters we want in each chunk. And then chunk overlap. So let's say we're going to create the two chunk out of this whole file. It might arbitrarily split somewhere, so we will have some overlapping part to them, so that the context continues to the next chunk. That is where this chunk overlap kind of a thing. Simple thing, we take this character text splitter, give it a chunk size through what we got, and eventually we will get that splitter object which will split our documents and will return the splits, or let's say we call them as the smaller documents. Those are nothing but the chunks, and they should be more in number compared to what we have. So we had two documents. Out of these two documents, we got actually the nine chunks, which can be of size actually 1,000 characters of each. And we can look at each chunk actually. So each chunk object has something called a page content. So we are accessing the first chunk, and let's look at what is that page content. Now, we didn't talk about what exactly data we have, because that is not the point of this tutorial. So let's say I have a data. So I created these two files using, let's say, ChatGPT. So one file I created, that write essay about India. So it was in text. I just converted it into the PDF so that we can also look at the PDF part of it, right? So it has, information about the India, its geography, climate, tourism, economy, all this kind of a small essay on India. And the other I generated is actually the relationship between the India and USA. So I asked, can you write one essay on India and USA? So I have these two sample files which represent our document. And see, those are the two files what we have given here. And then what we got, the first chunk, that India is a vast and diverse country. So whatever that particular chunk, right, which has 1.3 billion population and all these things. So this is how one chunk look like. So if you look at maybe the different chunk here, since we have nine chunk, let's say we look at maybe the fifth chunk here. Okay, this is related to some economic relations. So as name suggests, I think it might come from India, USA, TXT. Okay, so we have these chunks now, the small chunks which can we do embedding. So we're going to use OpenAI embedding. So we saw in again, okay, I have to go back again and again. I should have actually opened that thing in a new tab or somewhere. So you could see once we got the text splitter or the chunks actually, we want to create the embedding, and we can use OpenAI embedding or the spelling mistake, the OpenAI embedding, and we can also use the sentence transformer embedding, right? So let's use the OpenAI embedding for the purpose of this particular tutorial. So just like we have a multiple utilities to load the data, to split the documents, we also have utilities for embedding. So LangChain embedding, we can load the OpenAI embedding. And if you go to the LangChain, and if you look at models, and then you have large language models, as and then you also have a special section called text embedding models, and then you have embedding models from the different provider like Cohere, Gina, OpenAI. So that's why the LangChain, the things are awesome. Like you can switch between the different, let's say, embeddings. You can switch between the different versions of the language models, and that structure what the LangChain brings actually. So what we're going to use from the LangChain, we're going to import the OpenAI embeddings, which simply takes the name of the embedding. So I'm going to take one of the embedding available at the OpenAI, and then this is what the embedding instance. And here I'm just showing how it works. So you take that embedding instance, and you can simply call a function called embed query, which takes some text and eventually returns a result which will be an embedding. So I'm just printing actually the length of that embedding, which is 100 and sorry, 1024 dimension. We can even look at that embedding, which is nothing but the big vector, right? So I will print and maybe I will simply delete that again. So you see, this is the big array of numbers, right? Which is 1024 dimension. So this is a vector, right? Looks like. So we saw the embedding that we're going to use actually going to have a length of 1024 dimension. Now we want to store it somewhere, right? That's what the whole idea. We want to store this embedding in some kind of a vector store. So we're going to use the Pinecone, right? In the earlier videos also I have shown actually, Pinecone, how to create Pinecone. It's simply you go and use your you can log in with your Gmail account and you can simply create the index. But I'm going to show what is needed for this particular thing. So I am inside my Pinecone dashboard where I can create the index. So index is something where we can actually store our documents. We call it as indexing those documents, right? So what we require, let's go back to again our code section. So we just had an embedding capability which can generate the embedding for us, but we need a way to store those embedding. So what we will do, we're going to require the Pinecone. So there is the Pinecone Python library that we will install. And the meanwhile, what I'm going to do, we're going to create this index called LangChain demo. So let's create this index for LangChain demo so that we can put these documents, the chunks we got, we can put those chunks there. So let's go and create that particular index. So if you go to the this Pinecone console or a dashboard, let's call it console, you can click on a create index. And while create index, you can give the name. Let's I'm doing this LangChain demo and the dimension. We know it is 1024 because that's what the embedding dimension. And we're going to use cosine similarity rate for if you want to compare two vectors while getting, let's say, the most matching vectors. And there are different pod types. So let's say we are going to choose one kind of an instance or the pod which is good for the storage capacity, and we're going to create the index. It will take some time, a couple of seconds or something, right? So if you see, for each index we have some kind of an environment, we have a dimension. And then if you want to programmatically access this particular index, you will also require an API key. So you can copy that API key from here so that you could use that particular thing. And here is the index. So it is still initializing. Once it is initialized, we should see this coming to the green or something. And then we can actually this thing. So you could see, when we initialize the Pinecone, we take the Pinecone, which is Python library, import Pinecone, which is here. Actually, we can initialize Pinecone with the API key. Again, I have to make sure I delete this key also. And then the environment, we just saw the index as an environment, right? And then eventually the index name. And then this is the utility, or the, let's say, module from the LangChain. So LangChain supports a different vector source, not just the Pinecone. So if you go to the LangChain again, and if you go to the indexes section, okay, and if you look at the vector store, it is going to support a lot of different vector stores. So we're going to, let's say, check the Pinecone one, how to use the Pinecone. And so it will have, we can we can import the Pinecone from the, what is this, a LangChain vector store, and we're going to use that Pinecone, and that's what we are doing here. So we are importing the Pinecone vector store. That Pinecone vector store from the LangChain has a capability to update this index using the method called from documents. So we are calling the Pinecone from documents, and then we're going to give our documents, which is nothing but the chunks that what we created here. And then we're going to give the embedding, because we want to store the embedding and not the actual document. So it's also going to take the embeddings what we just so we are not passing embeddings, we are just passing, actually this is an embedding instance or the object which can create the embedding, which is nothing but the OpenAI embedding. So we pass the document, we pass the one embedding generator, better I call it embedding generator, and then the index name where we want to store those embedding, right? Let's look at whether we got our index running or not. You will see the index is ready by this time. And we could look at the index info. There is no vectors because we just created this particular index. Let's go and now see, because we saw we have 9 chunks, right? So it is going to insert now the chunk once I call this thing. So Pinecone from documents, and this is the detail we want. And if I run this thing, I should be able to create the index. I think the index got created. Let's go and check maybe this vector thing. Do I need to refresh this, yeah, it got automatically refreshed. I didn't do anything. So we got 9 total vector because we had a 9 chunk. So we know now our document got indexed. Now this is the time is actually to find the similar documents based on our query, and we know we have a document related to India and the relations of India and USA, right? So we create another small function. What it does actually, which takes our query, which is nothing but, let's say we can ask something like, how is India's economy? That's our query or the question. And then it takes, it is going to use the same index because this index has our documents embedding or whatever this thing. So it has a function, two functions it has actually. The one which result documents with some score, and the other one which simply returns the documents actually. Okay, so let's look at the first without the score thing that we can call actually, right? So we are calling this function called get similar docs, which is eventually going to use this index function, index get the similarity search, which is coming from the Pinecone because it is the Pinecone vector store utility or model what we are using, right? So that has a function called index.similarity search, which take the query that we want to search through the index, and then eventually the number of returns we got, right? So let's run this thing and see what we got. So when we ask how is India's economy, by default we're going to get k is equal to 2. So we get the two relevant document chunks written. So this is what we are getting written. So you could see we got the array of the document object. And that document object, each object has, so you could see we have two document object actually. One is here, the other one is there. So we got actually this control C control. Oh no. This is many places. Let me go back to again here. Yeah. So we saw we got these two document chunks here, and each of has a page content against which actually it got matched, right? And then we have a source from which file it came. So it is actually matching from india.pdf, india.pdf. So we could see the source with which it is actually the matching. And we could also, again, I could pass maybe the k is equal to 3 so that I can get the three documents. And now you see I got three document one, document two, and I got three documents, right? So we just want, let's say, one document. And let's pass score. We want score also because we want to see what is the matching score, which will be the relative score, whatever, not the relative, but let's say whatever the scoring mechanism Pinecone has. Now we could see with metadata as a source, we have also got one more option called the score, which is 68% matching, 65% matching. So we can say that by the score this particular chunk is matching, has more semantic similarity with the query than this particular chunk. That's what it actually means. Now, so we have now capability which can take any query and return the relevant documents. Now if I have to again go back to here, right, why do we need those relevant documents? Because we're going to take the query and the relevant documents we got, and then eventually give to some large language model which can answer query based on that particular context, right? So let's go back to again here, right, this thing. But actually the downstream function we require, which doesn't require the score, we just okay with the without score, we just want those similar documents in the return, right? Now let's create our final function. That requires what? That requires a large language model like a GPT-3 or GPT-4, right? So just like we had a utilities for document, loading those documents, splitting those documents, embedding, we also have a let's say module for the large language model, which is LLMs. So we can declare which large language we want to use. And again, since there are multiple providers, we're going to use the OpenAI. You can go always and read about more about the LLMs available here, right? And this is the LLM section, and there are a lot of different options are available. So what we're going to use, we're going to import LangChain.llms. We want to use the LLM from the OpenAI, and then we can create the LLM instance giving the name of the model. So we can try multiple model, and that's again the beauty of LangChain, right? So we know that the API request structure of the GPT-3 and GPT-4 is different. Let's say GPT 3.5, but still, since we have a wrapper around it, we don't need to worry about. We simply change the name of the model and it should definitely work. So for this case, we're going to use, let's say, GPT 3.5, which is, let's say, ChatGPT default model. And we're going to say that, hey, we're going to use large language model as a GPT 3.5. Now we got the large language model. The next thing we want the chain. This whole thing is we are talking about the lang chain, but where is the chain? Now this is the chain we got, right? So what exactly the chain here? Again, the chain is going to combine multiple components together. In our case, this chain is going to have one large language model, which we just created here. Then this chain also want to know, that what documents, the relevant document that it needs to take to actually give the answer. So there is a simple chain we call LangChain dot chain. Again, I have given here reference here, so you can read more about question answering over the docs, and that's what actually we're going to do here. So I made it more simplistic here, that from those chain which is related to the question answering, we're going to use we're going to import a chain called load qa chain, which is the question answering chain. And that chain requires which language model we're going to use inside that chain. And there is some chain type, I couldn't understand it well actually, but this is the default type for we have. You just think of that chain is going to, let's say, so this is the simplest change which doesn't have many steps actually into it, but let's say that is the chain for the question answering chain. So we created the instance of the chain just by specifying, let's say, the large language model that we want to use. Now we can use that chain to get the answer. Again, we declare one small function which actually take the query and then get first of all the similar docs, what we saw here right on the top, getting the similar docs. So we embed, or let's say integrated that function here, which can give me the similar docs. And then I want to run this chain, which is question answering chain, which takes the input documents, which is nothing but the similar documents we got from the get similar function, and eventually the question that, and it this chain already has information of which large language we want to use. So now we have all the parts together. Now we can run this get answer function, pass our query, and we should get actually the answer based on our documents. So when we call this function, the first thing happen, this is nothing but the semantic search happen. We got the similar docs, and then eventually we pass this to question answering model. And you could see we got an answer that India's economy is like whatever the sixth largest, maybe the data is the old because the model has been trained, let's say maybe 1 year back or 2 years back. And we got some 3 trillion whatever this is coming from, let's say, definitely it should be coming from india.txt. So if you go to the economy section, here we should have this information, the sixth largest economy and 3 trillion and all, that's all coming from here, you could see. So it is coming from the india.txt file, this particular thing. Now let's try different query. So how relations between India and USA, right? Maybe we could actually here this function when we define, we could print actually those docs. Where is that similar docs we got? Yeah, we got it here, right? Let's print them. Maybe that has the metadata information that we can see actually. Let's print those docs also every time we run the query, right? And we could see this docs we got here. Why I'm printing that doc object? Because it will have a source that it is answering from india.pdf, right? Now let's see from where did we answer this question. Okay, so it is going to answer from indiausa.txt. That is the most matching context it got, right? Indiausa.txt, this file. And this is actually the answer. Okay, if you got confused where is the answer, I can simply commit. This is just to wanted to show you what if you want to also display to the user from where exactly we got this information so that they can go and verify. Now we could see the relationship between the India and United States has improved over the recent years, and this is what the answer it can come up with based on this particular file called indiausa.txt. So this is how actually you can put all these components together. We are using this LangChain, the vector store, the OpenAI library for the model and all, and eventually we can build a question answering system over our own documents or the custom documents. So if you want to go back and again revise what we have done, right? So we had our own documents, which is let's say combination of PDF and text documents. We kind of use some utility from the LangChain and we split that text into the chunks. And then for each chunk, we generated embedding using OpenAI, and then eventually we put that whole thing inside the Pinecone vector DB. And to insert this into the Pinecone vector DB, first thing we actually went and created the index, which is called LangChain demo index, right? And then once we, so you can think of this like an offline process where you have thousands of documents, you just loaded those documents into your vector DB. So in the prediction time, during the inference time, we only got the query. We pass that query through the same embedding generator, which is, let's say, OpenAI, right? We got the embedding. Using this embedding, we got the relevant docs. So for this particular query, we got the recent two docs, or let's say two chunk, and then we take that query and those chunk, we call them as a context. And this query and context goes to a language model, like a large language model like GPT-3 or GPT-4, and we actually eventually got the answer from it. So this is our overall architecture, and this whole things we achieve using the LangChain, because LangChain has utility. One more thing we can do is actually, what if instead of GPT 3.5 we want to use, let's say, GPT 3? So we just need to change the model and it should work, because it's just a wrapper around it, right? So that we don't need to worry about changing the particular instruction or anything like that, right? So see what GPT 3 can answer, and we should get this answer. Now this answer is actually coming from the GPT-3. Same thing, instead of GPT-3 I can also use the GPT-4, because I have access to GPT-4. And so life becomes easy with the LangChain. If I have to move from 3 to 0, let's say GPT-4, I would have to modify my request structure, because this takes as a conversation endpoint and this is just a text completion endpoint, right? But since we are using the LangChain, I don't need to worry about it. Has been handled internally. It's just a wrapper, and I just changed the model name. And I think we this answer what we're going to get now, this should be coming from, let's say, GPT-4. Seems to be GPT-4 API is very slow. Okay, so this we got from the GPT-4. I hope you found this video useful. So this is just to show you how to put all the things together to actually build a question answering thing on top of your own knowledge base and documents. And as a freelancer, I get many such a projects and the request actually from the client who wants to build the question answering system like a chat gpt, but on their own documents and not relying on the not relying on the chat gpt memory. So this is really useful, and in today's world where the GPT-4 can process the whole big documents, it can take the bigger context. This thing, the answering through the document or the document processing or a document intelligence, whatever you call it, it's there are a lot of jobs even on the freelancing sites for those particular use cases. Okay, so if you haven't subscribed, please do subscribe and let me know in the comments if you have any doubts. I'm also going to release, let's say, a blog post mentioning all these details and explanation and also the code, and I will attach that link inside the description so that you can go and try. Okay, thank you.